video, we're going to talk about multiplying polynomials. So the video I uploaded before this, we talked about polynomials in general, some vocabulary related to them, what they look like, what standard form is, and how to add and subtract them. So if those are topics of interest to you, you can go click on my, channel and find the previous video to this one. But here we're going to just multiply polynomials together, and at this point in math you've probably actually already done this at one point, because let's look at this first slide. We've already learned how to use a property that is helpful in us being able to multiply polynomials together. It's called the distributive property. And what the distributive property lets us do is it lets us say, if I have something outside of a parentheses and then more than one thing inside the parentheses that's being added or subtracted, like we have right here, what I do is I distribute the number on the outside to what's on the inside, and I multiply both of the things on the inside by what's outside, and that allows me to get rid of my parentheses. So in this case, we do 5 times 2x, which is 10x, and then we do 5 times negative 8, which is negative 40. And we can't put these together because they're not like terms. One of them has an x, and one of them has a negative 40, and those they're not the same. Okay, so that would be our answer to this multiplication problem. Now, that's great. That's something that we've done before, probably at this point. So we're going to use the same idea to multiply longer polynomials together, and this is where it may seem a little bit more challenging or a little more unfamiliar. So on this first example, we say that we want to find the product. We've got 3x squared on the outside. That's a monomial because there's only one term on the outside. And on the inside, we've got 4 terms. So we don't have a special name for 4 terms. We just call it a polynomial. So we're doing a monomial times a polynomial that has 4 terms. And so we're going to use the distributive property. I'm going to do 3x squared times x cubed. Now I want to remind you of something that you should have done fairly recently, which is that if I want to actually multiply this together, 3x squared and x cubed, the x's combine by us adding the exponents. X squared is saying there's an x and an x, and then x cubed is saying that there's x, and then we combine those into x to the 5th, which is the same as saying what 2 plus 3 is. So the first term turns into 3x to the 5th. And then I keep going. I distribute to the next one. And so we can either write it out. We've got 3x squared times negative 4x squared, and then do it, or it may be that we can do it in our head. Either way is typically fine. You just have to know what you need to do to figure it out. But what's happening here is we're going to do the 3 times the negative 4, because those are just normal numbers that we're multiplying together, which gives us a minus 12. And then x squared and x squared, when we multiply them together, give us x to the 4th, because I add their exponents together. And then we're going to do 3x squared times 7x. So we can write that out and say, okay, I need to do 3 times 7, which is 21. And I need to do x squared and x to the 1st together, which gives me 2 plus 1, which is x cubed. And finally, we're going to do 3x squared times negative 2. And so that's going to be 3x squared times negative 2, which means the 3 and the negative 2 multiply to get negative 6, and the x squared doesn't have something to combine with, so it stays x squared. A trick to help you with knowing, well, this would be more of a trick to telling if you did something wrong. If up here inside of our parentheses, if none of these are like terms, because they have different exponents, then our answer should not have any like terms. If our answer ends up with like 2 different places where there's an x squared, but up here we didn't have anything that was like terms that we could have added together, we've done something wrong. If all of these exponents are different, which they are, there's 3, 2, 1, and 0. If all of these are different, then all of these exponents should be different. And they should be different by the same amount. Like this exponent went up by 2 because of the x squared. This one went up by 2 because of the x squared. 2 because of the x squared. And 2 because of the x squared. Sorry, I got confused. This was 0. It went up by 2, and now it's x squared. So there are some ways like that that we can kind of check our answer without necessarily having to think about doing the whole problem again, which a lot of times doesn't help us find our mistake because we just do the same mistake over again. So that's if we're taking a monomial and multiplying it by any size polynomial. We just want to use a distributive property. Now let's try on example 2 doing something a little different. We're going to use the FOIL pattern to find the product of a binomial times a binomial. The FOIL pattern is a mnemonic device that helps us be able to multiply binomials together. Because one way to do it is the distributive property, where we're going to say, I'm going to take 2x and multiply it by the first thing, 2x multiply it by the second thing, then take -5, multiply it by the first thing, -5, multiply it by the second thing. That's one option, and that's a perfectly good option if that's the way you want to go. But there is another way called foiling, and what this stands for is first, outer, inner, last. And even if you decide that you like the other way better, it's still helpful to know at least what foiling means, because it's a word, it's a device that lots of teachers tend to use. So you might hear it later on in a different math class, and so it's helpful to know that foiling means we're going to multiply these two binomials together in a certain way so that we'll be able to get it right. So when we have these words, first, outer, inner, last, they're telling us what to multiply. When it says first, I want to multiply the first term in each parentheses together. So I'm going to do 2x times -4x. And that's going to give me my term of that goes with first. So 2x times -4x is -8x squared. The next thing I want to do is outer. So if I think about the outside two terms, the outer terms compared to the inner terms, that would be the 2x and the 1. So we're going to multiply 2x and 1 together, which is just 2x. So our next term is 2x. Then I'm going to multiply the inner terms. So the two terms that are the most inside, which is -5 and -4x. Notice that I'm taking the signs with the terms. I'm not just taking 5 or just 4x, that the negatives in front, those matter, and I need to actually think about them when I'm multiplying. So the negatives will cancel each other out. 5 times 4 is 20, so this would be 20x. And then last, I take the last term from each parentheses and multiply it together, which will be -5 times 1, which is -5. So when we FOIL, or in general when we have a binomial times a binomial, almost always there will be like terms on the inside. Okay, so that trick I told you on the last example, that only works if it's a monomial times something. If it's a binomial or something bigger times something that is a binomial or bigger, then we do end up getting like terms in our answer that we have to put together. So in this case, I'm going to do 2x plus 20x, which is 22x. So my answer is -8x squared plus 22x minus 5, like so. So that's an example of foiling. Whenever we don't have a binomial times a binomial, what we normally do is we go back to using the distributive property. And this would work with a binomial times a binomial as well. We just a lot of times choose to use foiling instead. What I'm going to do here is I'm going to start with the x, and I'm going to take the x and multiply it by everything that's inside of our parentheses, the second parentheses. So I'm going to do x times x squared, which is x cubed because there's an x to the first and an x squared, so you add their exponents together. And then I'm going to do x times -2x, which is -2x squared, because there's not a number in front of x, so it gets the number that this one has, and then we add our exponents, which are both 1s. And then I'm going to do x times -6, so I get -6x. That's the x distributed. We're going to do the same thing with the 9. I'm going to distribute the 9 to the x squared, to the -2x, and to the -6. So that's going to give me 9x squared. Now, I could write that out here to the side and make this all be in one line. Or I could kind of use what we did in the adding and subtracting video where we put like terms under other like terms. So I could write the 9x squared right here underneath my other x squared so that in a second I can easily see where my like terms are. So I can do 9 times negative 2x, which is negative 18x, and then 9 times negative 6, which is negative 54. So because I've lined it up this way, I can add vertically. Like, because negative 54 doesn't have anything with it, it's going to stay negative 54. But negative 6x and negative 18x, those are going to add together because they're like terms. Negative 2x squared and 9x squared are going to add together because they're like terms. And the x cubed doesn't have anything to add with, so it stays x cubed. And because I just added all my like terms together, now I don't have any like terms, and this would be my answer. So whenever we have two terms times something that's bigger than two terms, we have to use the distributive property like this. We can't try to FOIL this because there's too many terms for us to actually use the FOIL acronym. Also, typically what people will do to mess this up is they just won't actually multiply both of the things through all the way, and so they'll leave things out, and that's not going to give you the right answer if you leave things out. That's not how that works. So final example actually has two problems, so I guess it's the final two examples. We're going to find these products, and these are special cases, and so this is where if you're actually using the same book as me, and so you're like, why does it say 10.2 and 10.3? This is what 10.3 is about, is the special cases of things we can multiply together. Let's multiply x plus 7 times x minus 7. If we use the FOIL method, we'd say the first terms are x and x, so we multiply and get x squared. The outer terms are x and negative 7, so that's minus 7x. The inner terms are 7 times x, which is 7x. And the last term in each is 7 times negative 7, which is negative 49. And we have like terms in the middle because almost anytime we do a binomial times a binomial, we will have like terms in the middle. Negative 7x plus 7x is 0x, which means that they cancel each other out. You have to have opposite signs and the same number and the same like x or x squared or whatever it is in order for you to actually cancel out. If they're the same sign, they don't cancel, they actually go together. And then that leaves us with the negative 49. What's happening here is this is a special thing called the difference of two squares. Or is it? No, I feel like it's called the sum and difference formula. I don't know. One of those two. But the name isn't really what's important. What's important is the reason this worked out the way it did, where our middle terms canceled out, has to do with the fact that we had the same thing in both parentheses, but that one had a plus and one had a minus. So having x plus 7 and x minus 7, where the x and the 7 matched in both, but that one had a plus and one had a minus, made it so that we could have predicted ahead of time the middle terms would cancel out, and that we'd be left with the x times the x and the 7 times the negative 7, which is x squared minus 49. So what that means is that if you're given some other random problem like this, and you recognize that they have the same thing in their parentheses except that one is a plus and one is a minus, then you can just say, all right, I'm going to do 3x times 3x and 6 times negative 6, and voila, that's my answer. So it's like a pattern that you can rely on, that if this is what you have, then it should work in this way. Same kind of thing is going to happen on B here. If we don't know what the pattern is, then what we have to do is remember that 2x minus 9 squared is saying 2x minus 9 times 2x minus 9. A lot of people will just try to square both of these and say that it's 4x plus 81, or they might actually mess up more than that and say that, x squared, and say that it's 4x squared minus 81. And that's really close to the right answer, but it's not the right answer. And doing it that way shows a lack of understanding of what squared means. Squared means I have the same thing twice, so I would need to FOIL this out. 2x and 2x is 4x squared. Then we are going to do 2x and negative 9, which is negative 18x. And then negative 9 and 2x, which is also negative 18x. Negative 9 times negative 9 is 81. So the pattern here that happens is that the middle terms should end up being the same, so they don't cancel each other out. You add them together so that it's double what one of them was. So our answer is 4x squared minus 36x plus 81. And I know that some of us are thinking, like, that's super close to what we would have gotten if we were lazy with our squaring. And yes, it is close. But as a math teacher, you look at someone who's written this as their answer and you say, you don't understand what you're doing, so that's not close at all. It's the intention behind the answer sometimes that matters more than the answer itself and how close it is to the right answer. So this also is a pattern. If we see something squared, then what should happen every time is that the first term we get is the first term squared. The third term, so this 81, came from squaring this number. And the middle term comes from us multiplying this together and then doubling it because we'd get that term twice. And so that means if I make up some other random problem, like x plus 3 squared, I could write it out as the first term squared, the second term squared, but it goes out here. And then in the middle, I do x times 3, which is 3x, but I double it and get 6x. So if we recognize that pattern, if we understand that pattern, we can get to the answer faster. But it's perfectly fine to instead write the problem out and FOIL it or use the distributive property. It all depends on which way that you are more comfortable doing it. So if you recognize the pattern and can use it, that's great. Otherwise, just FOIL like normal. This has been multiplying polynomials, including special cases like the sum and difference of binomials and like squaring things, which is what this last slide is. So thank you for watching. Have fun.